Hi everyone, I am Grishma from CSCA section from Shankar Institute of Technology. Today my tech talk topic is interpolation. Interpolation is x0, y0, x1, y1, x2, y2, etc. xn, yn be a set of tabulated values of x and y. Now to calculate the values of y at x, which is nearer to the initial and end value of the tabulated values by interpolation technique. In the interpolation technique, finite differences plus 4 vital roles. Finite differences are classified into 3 ways. They are forward differences, backward differences and central differences. Forward differences, for example, y0, y1, y2, y3, etc. yn are n plus 1 values of y. y1 minus y0, y2 minus y1, y3 minus y2, etc. yn into yn minus 1 are called the front order forward differences, which are denoted with delta y0, delta y1, delta y2, delta y3, etc. delta yn. y1 minus y0 equal to delta y0, y2 minus y1 equal to delta y1, y3 minus y2 equal to delta y2, y4 minus y3 equal to delta y3, etc. So on. yn minus 1 equal to delta yn minus 1. Again, the differences of first order differentiations, we get second order forward differences. That is delta y1 minus delta y0 equal to delta square y0. Delta y2 minus delta y1 equal to delta square y0. Delta y3 minus delta y2 equal to delta square y2. Similarly, the differences of second order forward differences, we get the third order forward differences. Here the symbol delta represents the forward differences operator. So forward differences table we can create for that values. Then the backward differences. y0, y1, y2, y3, yn, etc. yn are the n plus 1 values of y. y1 minus y0, y2 minus y1, y3 minus y2, etc. yn minus 1 are the first order backward differences, which are denoted with nabla y1, nabla y2, nabla y3, so on. Nabla yn is nabla y1 equal to y1 minus y0, nabla y2 equal to y2 minus y1, nabla y3 equal to y3 minus y2, so on. Nabla yn into equal to delta n minus yn minus yn minus 1. The differences of first order backward differences, we get second order backward differences. Delta y2 minus delta y1 equal to nabla square y2. Nabla y3 minus nabla y2 equal to nabla square y3. Nabla yn minus nabla yn minus 1 equal to nabla square yn. So where nabla is called as the backward difference operator. So we can create the table for that values. So central differences. Central differences means y0, y1, y2, y3, yn, so on. Yn are n plus 1 values of y. So y1 minus y0, y2 minus y1 and y3 minus y2, etc. yn minus 1 are finite order first order central differences, which are denoted with sy1 by 2, sy2 by 2 and sy3 by 2. So again the differences of first order central differences, we get the second order central differences. So then the meaning of interpolation is a satisfactional method by which related known values are used to estimate an unknown price or potential yield of a security. Interpolation is achieved by using other established values that are located in sequence with the unknown values. Interpolation is a truly a simple mathematical concepts. The example of interpolation is the process of estimating unknown values that fall between known values. In this example, a straight line passes between through 2 points of known values. So the interpolated value of the middle point could be 9.5. So the diagram is the example for the interpolation. The interpolation, why use interpolation statistics? How we use in interpolation? So the interpolation formula can be used to find the missing values. It is used to find the missing values. However, by drawing a straight line through 2 points on a curve, the value at other points on the curve can be approximated. So, in the formula for interpolation, x sub 1 and y sub 1 represent the first set of data points of the values observed. Here we observe the diagram. Which of the following methods are used for the interpolation? What methods we use in interpolation is, for example, interpolating the value requires or is done by curve fitting and regression analysis. Explanation of that. Interpolation provides a mean for estimating the function at the intermediate points. Who created the interpolation? In a letter to Collins dated November 23rd, 1670, Gregory describes the now well-known Gregory Newton interpolation formula for equal interval data. 1675, Newton begins his fundamental work on the topic and eventually lays the foundation of classical interpolation theory. Here, what is the Lagrange's interpolation means? In numerical analysis, Lagrange's polynomials are used for the polynomial interpolation. For a given set of the points with no two xj values equal, the Lagrange polynomial is the polynomial of the lowest degree that assumes at each values xj a corresponding value is yj. What is the polynomial interpolation? In numerical analysis, polynomial interpolation is the interpolation of a given data set by the polynomial of lowest possible degree that passes through the points of the data set. Newton interpolation polynomial formula is, it is also known as the Newton polynomial. In the mathematical field of numerical analysis, a Newton polynomial named after its inventor, Isaac Newton, is an interpolation polynomial for a given set of the data points. What is an interpolation calculator? It is the interpolation diagram. So, in the mathematical field of numerical analysis, interpolation is a type of estimation. So, a method of constructing new data points based on the range of discrete set of known data points. What is the linear interpolation method? So it is the diagram of linear interpolation. So in mathematics, linear interpolation is a method of curve fitting using linear polynomials to construct the new data points with the range of the discrete set of known data points. So we know the interpolation for being it is used to continuing the x values and y values. Thank you.